Hey everyone, we're going to solve a system of equations in 3 variables. So these are our 3 equations. And for this one, what we've got to determine is which variable do we want to eliminate. So I think with this one, for me, you can eliminate any of them. We could do the y. I think the z would be kind of hard. I'm going to go ahead and do the x because we can eliminate those two x's just by subtracting. So I'm going to take equation 2 and subtract equation 3. So I'll just do it this way, write it down. And I'm going to subtract. And I put subtract here, with the parentheses, I mean each piece. So x minus x is 0. Negative 1 minus positive 4 is negative 5y. 1z minus a negative. If you hear yourself say minus a negative, it means plus. So that's going to be plus 6z. 3 minus 0 is just 3. So we don't need this 0 because that just looks silly. So there we have that because these x's canceled out. Now I'm going to take either equation 1 and 2 or 1 and 3. I think I'll do 1 and 2 because the 2 looks easier. What I'm going to do is write down equation 1. And what I think I'll do with this is just multiply each piece through by negative 3. So I'm going to multiply each of these by negative 3. That's going to give me negative 3x plus 3y minus 3z equals negative 9. And then on this one, I'm going to add, because I want my signs to be opposite if I'm adding. If they're the same, like they were here, they were both pluses, that means I subtracted. So the three x's cancel, and I have negative 2y plus 3y is just y, and 4z plus a negative 3z is just going to be z, and 15 minus 9 is 6. So now I have a system of equations of these two. I reduce them down. So I have negative 5y plus 6z equals 3. And I think what I'll do is solve for z here. I mean for y. Either y or z. I'll just do y. So if I solve for y, I get y equals 6 minus z. So I'm going to use substitution and plug this in this y. So we have negative 5 times 6 minus z. And then we have plus 6z equals 3. So it's going to be negative 30 plus 5z plus 6z equals 3. I'm going to add 30 to both sides. And this is 11. So I'm going to get 11z equals 33. So z equals 3. Again, there's really not any order, but you can do these in different ways. You could have solved for z and got the same, get your y first if you wanted. So I got z first, is 3. Now I'm going to go ahead and write these on the next slide, and I've got to remember them. So I have, I'll just have to go back. Negative 5y plus 6z equals 3. Negative 5y plus 6z equals 3. And the other one was y plus z equals 6. Y plus z equals 6. And we found out that our z was 3. So z equals 3. So let's plug in 3 in one of these equations I'll do this one because it looks easier. Y plus 3 equals 6. Subtract 3 from both sides. So you get Y equals 3. So Y equals 3 as well. And then to get my Z, I'll plug in X and Y here. So X, or I had to get my X. So X minus 3 plus 3 equals 3. So just using that equation. This is 0. So X also equals 3. So if you write it out, you'll get 3, 3, 3. And they were all 3s. If you want to double check, just pick one of these and check and see if we did this right. So let's see, I'll plug it into this one. So everywhere I'm going to put 3. So 4 times 3 minus 5 times 3. That should equal 0 if we did it right. So we get 3 plus 12 minus 15 should equal 0. And that's correct. So we have, because this is minus 3. 3 minus 3 does equal 0. So we did do it correct, and this is your answer. Thank you. Have a nice day. Bye-bye.